Okay, hi guys, it's Mrs. Millicent. Let's do the check your understanding on page 168, okay? All right, we've got data collected on the weight of a male white laboratory rat for the first 25 weeks after its birth. A scatter plot of the weight in grams and time since birth in weeks shows a fairly strong positive linear relationship. The linear regression equation is the predicted weight equals 100 plus 40 times the time, which is weeks since birth, models the data fairly well. So let me put my predicted weight equals 100 plus 40 times. So this is grams, and this is weeks since birth. Okay? So first things first, we got to identify the slope and the y-intercept and interpret them in context. So what is the slope? So if we remember from our reading, this is, let me rewrite this. The predicted y, the predicted response is a plus the slope times the explanatory, okay? So our slope is the b. That's our slope in this, in this case, which is 40. So what that means is for each additional week that the rat gets older, we predict its weight to increase, because it's positive, by 40 grams. Okay, let me write that down. For each additional week the rat is older, we predict its weight to increase by 40 grams. So there's my B, okay? Increase is because it's positive, okay? And grams is the value of the prediction, okay? You got to make sure you say predict, okay? 2 says, what's the y-intercept, and explain it in context. So our y-intercept is the A in the equation. So in this case, it's the 100. So what that means is, if I put a 0 in for x, thinking back to, math 1, if we put a 0 in for x, that's our y-intercept. So what's a 0 week since birth? Okay, the 0 week since birth is when the rat was born. So my interpretation is when the rat is 0 weeks old, okay, basically a newborn, we predict its weight to be 100 grams. Okay, and that makes sense. It's born, it weighs 100 grams, and then every week after that, it gains 40 grams a week, okay? So that makes sense. A lot of times your y-intercept does not make sense, and if it doesn't make sense, you're just gonna write a little line down here that says, doesn't make sense. But this one makes sense, so I'm not gonna write that. Okay, 3 says, predict the rat's weight after 16 weeks. Well, all we have to do is plug in 16 here, okay? So my predicted weight is just going to be 100 plus 40 times the 16 weeks from birth, okay? So my predicted weight, throw that in the calculator, and it is 740 grams, okay? Done, okay? Number 4 says, come on up here. Number 4 says, should you use this line to predict the rat's weight at age 2 years? Okay, use the equation to make the prediction and think about the reasonableness of the result. Okay, come on back down here. So again, if we use our equation and to predict the weight of the rat at 2 years, all right, what's 2 years in weeks? 1 year is 52 weeks, so 2 years is what, 104 weeks? Okay, I didn't put that in the calculator. Whoops. 104 weeks. Okay, so the weight would be 4,260 grams, okay? I don't know what that is as far as pounds. I think it's something like 9 to 10 pounds. That's huge, okay? That's huge. Unreasonable, okay? A rat's not going to grow at the same steady rate over 2 years, okay? This is not a good prediction. This is called, are you down here? This is called extrapolation, because we are trying to predict something that's too far outside of our data range. Come on up here. This data came from the first 25 weeks after its birth. So we can only predict the rat's weight within 2 years, 2 years and a month, okay? We shouldn't go outside of 2 years. Oh, no, wait, 25 weeks. That's not 2 years. I'm thinking months. What's 25 weeks? 4 weeks? 5 months? 5, 6 months? Yeah, 5, 6 months-ish, okay? So we shouldn't predict outside the range of the data that we collected. So our 2-year prediction is totally extrapolation, and it's an unreasonable prediction, so shouldn't do it, okay? This prediction was fine. 16 weeks is within the first 25 weeks, so this prediction is fine, okay? Okay, great. Oh, there it told us 400, whatever. Okay, thanks. See you next time. Bye. Oh, let's get the kitty. There's little kitty. Kitty, say hi. Okay, there's little kitty.